The biggest thing yesterday, or the biggest question that I kept getting yesterday was, like, whenever we did the trig ratios of the various angles, and we drew the triangle and went from there. And the biggest question I got from people was, what are we using this for? Are we just putting it in for just to have the trig ratios, or what are we doing? Well, what it's doing is it's actually getting you to where you can find the actual angle measurement given a certain coordinate. Okay, because everything we do, we can always draw a right triangle. Okay, and similar to whenever we did like the inverse tangent or the inverse sine of our value, we can use the coordinates, or we can use the sides of our triangle that we have to figure out what is the actual degree measurement that we're working with. Okay, depending on where it's at, and kind of go from there. Okay, to use what's called the reference angle to figure out how many total degrees did I actually wrap this angle around the origin. Okay, everything we do here is always going, whenever we have a reference angle, your reference is always going to be the x-axis. Okay, so as far as what you're going to use, you're always going to use a reference of either pi or 180 or 360 and 2 pi. Now, it's dependent on where your actual angle lies and how you're going to set it up. So if you notice that on kind of below where it talks about the reference angle and you have the various graphs, notice that everything above, okay, here, or everything, in quadrant 2 and quadrant 4, we're going to take that angle and we're going to subtract. We're going to take 180 or 360 and we're going to subtract our original angle to find our reference angle. Whereas here, down in angle 3, or quadrant 3, it's going to be reversed. So we're going to take our actual angle measurement and take it back to 180. Okay? Everything we do, we're always going back to the x-axis. So like if we would draw our triangle, we would go there if it's in quadrant 2. Okay, to make up our actual angle. Same way, if we were going this direction, if it's in quadrant 3, we're going to go back up to the x-axis, and we would make everything there. Okay, since your actual angle is bigger than the 180, you're going to put it in front. You should always have a positive number. Okay, you should always have a positive angle. If you subtract, like if you get into quadrant 3 and you take 180 minus 243, you're going to get a negative angle. We don't want a negative angle. Everything we do is always going to be a positive angle. Okay, so that's key. Same way here with, if it's in quadrant 4, I would just take everything straight up and I would have my reference angle there. Okay, my reference angle that I deal with my triangle is going to be the same value, and we'll talk about that in a little bit, is going to be the same value as far as my trig function. So like sine of whatever angle I'm dealing with is going to have the same value as if it's all the way around. It's just a matter of, is it positive? Is it negative? Kind of what we've already talked about yesterday with our quadrants. Okay, and remembering that quadrant 1, everything's positive. Quadrant 2, which one's positive? Sine. And then quadrant 3, tangent. Quadrant 4, cosine is always positive. So that means that everything else, or at least as far as my original functions of sine, cosine, and tangent, the other two are going to be negative, except for in quadrant 1. Quadrant 1 is always positive, okay, because every value is positive. Okay, so if we have to find the reference angle, or theta prime, however you want to look at it, okay, for each of the following angles. So what we want to do is first know where is it at, and So am I going to take 360 and subtract my angle? Am I going to take 180 and subtract my angle? Or am I going to take my angle from and then take 180 from it? Okay? Because it's always going to be positive. It's always going to work out in that direction, regardless if we go in a negative direction or a positive direction. So like if I have theta of 345. So where is a 345 degree angle going to lie? Is it going to be in 1, 2, 3, or 4? It's going to be in 4, right? So if we think about it, it's going to be somewhere down here. Okay, probably about like that. So then we need to go up from there. So we always go to the x-axis. So is that going to be 180 degrees or is it going to be 360? What are we going to do to find the actual angle measurement of that's right inside there? 360 minus 345. So it's going to give me a 15 degree angle, okay, as far as my triangle is concerned. Now, same way, if we have 5 pi over 6, so hopefully you had that one written down on your unit circle somewhere. Where is it at? Is it in 1? Is it in 2? Is it in 3? Or is it in 4?
2.
It's in 2. Okay, it's in 2, somewhere over here. What am I going to do? I need to drop it to the x-axis. So I'm going to deal, it's on the left side of my y-axis, so it's going to be 180. So if here's 180, or 180 was also from your circle quiz today, pi, very good. Okay, so I need to subtract either, I need to take pi from 5 pi over 6, or I'm going to take 5 pi over 6 from pi. So which one's it going to be? Which one's going to keep everything positive? Pi minus 5 over 6. 5 pi over 6, excuse me. Now, if you're not sure and you need to have the common denominators, remember that's just going to be 6 over 6. So 6 pi over 6 minus 5 pi over 6. Pi over 6 or 1 pi over 6, either way. Now, what if I go in a negative direction? So if I basically peel back 135 degrees, am I going to end up in 1, 2, 3, or 4? If I peel back and go under instead of over the top, asking or telling?
I think it's 3,
4? Remember, every one of those lines is 90 degrees, right? So if I go to here, there's 90. If I go to here, there's 180. So where's it going to end? Where is 135 at? Is it more than 180?
No.
Is it more than 90?
Yeah.
Yeah, so it's going to be somewhere down here, right? Because it went negative, right? Okay. So if I'm down in 3, a negative 135 degree angle is going to be the same as what? A positive what degree angle? So I got to do a little bit of work here. What's going to get me back to a positive value?
360.
360 to it. So 360 minus 135. So then where am I at? 225. Now what do I need to do with the 225 to get me back to this angle right here? Nope. What number am I going to subtract? What if I would have went in a positive 225 degree direction? What would I have done? What do I need to subtract from 225 to keep it positive? 180. So So I'm going to subtract 180. That's going to be the same thing as 45 degrees. Because this is 180. So going in a negative direction is going to be the same thing as going in a positive direction as well. So then, same way when you're kind of up against the clock here. Same way if you have angles that are over 360, or if you go in a negative direction that are more than 360 and you go in a negative direction around, basically what you want to do is you want to subtract or add 360 or 2 pi until you get it to a positive value. So like if I have a 580 degree angle, I'm at least going around once and then I'm stopping. Remember, it's a circle, so if I go around, it doesn't matter, okay, if I go 1 revolution around or 7 revolutions around, or if I just go part of an angle, I'm still going to end up at the same spot at some point. So like if I have a 580 degree angle, then as far as standard position, wherever it's going to be, all I'm going to do is take 580, subtract 360. How much is left? 220. So that gives me where my standard angle is at. Okay, that tells me basically I'm somewhere down here. Is all that does. Now, just like I did before, I still need to get back to my triangle, or make my triangle. So how do I find this red angle here? What's this actual angle measurement? It's 220 from there to there. What's the actual blue part? Or the red part, rather. 40. How'd you get 40? 220 minus 180, right? Whenever I deal with radian measures as far as my angle. Okay, everything's in terms of pi, so it's 8 pi over 3. So I need to get it back to where my original spot is. I went at least 1 full rotation around. So I've got to know, all right, if it's 8 pi over 3, I need to at least subtract 2 pi from it. So if I have 8 pi over 3, I'm going to subtract 6 pi over 3, because that's the same thing as 2 pi. So as far as like standard position, it's just going to be at 2 pi over 3. Hopefully that was one you got on your quiz. So again, it becomes that where is 2 pi over 3? Again, hopefully you got that. So if we take our angle, is it in 1? Is it in 2? Is it in 3? Or is it in 4? Where's 2 pi over 3? Where was it at? It was in 2. Okay, it was somewhere over here. So again, I'm going to drop down my line. So if that was 2 pi over 3, what was the angle of the green area? Pi over 3. Same way if it's negative. Now, like on C, where it's negative 13 over 6. It's still going to be, like in this case, I'm going to really need to add almost 4 pi to it, because it's going to go around and it's still dropping down to be a negative, because I need to find the positive value of it. Okay? So like in this case, it's going to end up being like 11 pi over 6. Okay, so then I've got to come back to my angle to go from there, where I think it's just going to be pi over 6. Okay. Last thing. So it says evaluating trig functions using reference angles. Okay. So basically what you're doing, this is kind of where we're at as far as that question of where is all this going to fit in? Well, what it's going to do, it's going to give you your actual value. Or we can find from what we did yesterday and using the trig functions, we can plug it back in to figure out if I know what my reference angle is, then I can figure out, okay, if it's in quadrant 3, what is, if my reference angle is 45 and it's in quadrant 3, well, that's really 45 plus 180, so it's really a 225 degree angle. Okay. Same thing like it says with sine of 300. So with sine of 300, where is sine of 300? Where's a 300 degree angle? Is it in 1? Is it in 2? Is it in 3? Or is it in 4? It's in 4, right? Okay, so it's somewhere down here. So if I have a 300 degree angle there, and I need to figure out, well, what's my reference angle? What's my angle here? 60, right? So I want to know what sine of 300 is. Now, it says to give me the exact value. So when it says exact, that means it's going to give me things like pi over 6, pi over 4, okay? 45, 30, 60, stuff like that. It's not going to give me some random number like the square root of 34 like it did yesterday. Okay? It's going to give me nice, neat numbers. So if it's sine of 300, if we are down in quadrant 4, first off, is sine going to be positive or negative? It's going to be negative, right? Because what's positive? It's C, A, S, and T. Okay, so sine of 300 is going to be negative. It's a 60 degree angle. How can we, if there was only a way, if there was only like 5 fingers that would just show us and just slap us on the head and be like, hey, I can figure this out. Wait a second, there is. Don't use my left hand because my ring kind of hurts when it hits my head. So, if I have sine, and if everybody has, hey, there's my thumb. Here's 0, there's 30, there's 45, there's 60. Remember, the palm is just the square root over 2. Cosine of whatever my angle is and sine of whatever my angle is. Is sine the top or the bottom? What? Well, you need to remember this. What is it, Phelan? Bottom. Okay, so that means cosine's the top. Is cosine my x value or my y value? It's x. That's y. So then, if I have a 60 degree angle, so it just goes back to using your hand. The biggest thing I've got to know is that it's negative because it's down in quadrant 4. So then I'm going to go to my hand here. I'm going to go 1, 0, 30, 45, 60. Boom. Right there at the pointer finger. Bottom side is sine. So how many fingers are below my hand here? Or below the bend of my finger? 3. So what is the exact value of sine of 300? Negative square root of 3 over 2. Holy cow. There's my exact value. Same way if it would have said, what's cosine of this angle? Well, I do the same thing, but what would my cosine value be? It would be 1/2, but what would it have to be? It would have to be positive. Well, what if it was tangent? I could still do tangent here. I can still do secant. I can still do cosecant. It all comes back to that first quadrant and then making sure you know what's positive, what's negative. Is sine positive? Is sine negative? Is tangent positive? Is tangent negative? Okay? Remember the spots on your hand. Okay? Because it truly is your true cheat sheet that can get you through everything that you need here.